Okay, so in this question, we've got forces here, 60 newtons, 85 newtons, 40 newtons, okay, which I've labelled here on my x and y axes, okay. And by the way, it's important to remember with these questions, this 60 newtons isn't going up, right, into the sky, okay. So that's why you've got to be careful not to call this sort of vertically, because it's not going up in the sky. You've got to appreciate this is happening on the ground, right. That's why we've got that word coplanar, right. Coplanar just means in the same plane, right, on the same sort of platform, so to speak. All right, so this is all happening on the ground, if you like, and we're looking as if we are flying above and we're looking down on it. So there's a particle here, and there's some sort of force pulling on this particle in this direction, that direction, that direction. A bit like a tug of war, isn't there? Multiple sort of tug of war going on. All right. But that isn't up, right? That's why you've got to be careful when I call this here. I call this my x-axis, that's my y-axis, yeah? Okay, it's all happening on the ground, so to speak. Now, when we resolve the forces, okay, that's easy. Let's go in the y direction, the x direction there. Now this here, don't forget, right, will have a component in the x and the y direction, because it's sort of pulling at an angle, isn't it? Okay, so it will move in the x, but also y. Now to get the x component, don't forget the adjacent is needed there, yeah? So that will, with the angle there, so that'll be 75 cos alpha. And then for the y component, it'll be the opposite one, it'll be 75 sine alpha. And cos alpha and sine alpha are needed, but if you note in the question above, it actually tells you that tan alpha is 3/4, okay? It does tell you that. So if you draw a triangle, right, and of course you remember that tan alpha is opposite over adjacent, isn't it? So the opposite would be this side, so that'll be 3, and then the adjacent would be this side here, which would be 4, okay? And then of course you've got your hypotenuse here, okay? So then that enables us then to get the cos alpha, which would be adjacent over hypotenuse, so that would be 4 over the hypotenuse. Now, you can work that out, can't you, the hypotenuse, if you know it already. It's the 3, 4, 5 triangle. But if you didn't know it, use Pythagoras. That squared plus that squared is 25, and then square root it gives you 5, right? So it'll be 4/5, and sine alpha will equal opposite over hypotenuse, which is 3/5. Okay, so then we now we need to work out the resultant force. This isn't in equilibrium, okay, so it will be moving, okay. So the overall effect of these forces means that this thing will end up moving. So we'll resolve in the x direction. So we have 85 plus 75 cos alpha. Now cos alpha I'll just replace with what I know there, 4/5. Take away then what's opposing it, which is 40. So let's work that out. That comes out to be 105. And let's work out in the y direction. Okay, so you've got 60 going one way, take away then 75 sine alpha, which is 3/5 the other way. And we get 15. Okay, both newtons, right? And we can get the resultant force, can't we? Okay, so the resultant force is the resultant direction as well. Okay. So it's important to recognise 105 in the x direction, only 15 in the y direction. So the resultant is going to be heavily sort of going in that close to that x direction. So the angle here is going to be small. And then to get the resultant, don't forget, the resultant is just the result of the 105 going across and the 15 going in the perpendicular direction. So to get r here, you just use Pythagoras, yeah? So r squared would equal 105 squared plus 15 squared. So r will equal the square root of all that. So we'll work that out now. What have we got? So 75 root 2. Okay, so we can leave that like that. And then we can work out this angle as well. Okay, so the angle then will be opposite over adjacent, tan of that. So tan, so that means then tan to the -1 on my calculator And I get, yeah, as I said, small angle, 8.1 degrees. Okay, so we've got the resultant force and the angle it makes. Now, part B, it says deduce the magnitude of the acceleration of particle P. And we need to appreciate that this particle is moving, isn't it? Because the force is, there's a resultant to it, and it's going in a certain direction. It's going in that direction of 8.1 degrees. But ultimately, okay, if we think of it moving, right, and there's a force making it move, okay, we can use Newton's second law of motion, all right? So if I model that particle, right, and I know it's sort of going in that direction, but when I do a force diagram, all I'm really interested in is all the forces. Okay, so I know the force, the resultant force is 75 root 2. Okay, now we don't have to worry about all the other forces acting on this particle, because remember, that represents the moles, isn't it? That represents the moles. 75 root 2 is the result of all of those forces. So we can think of it as just one force, right? That's the way I would go about it. Think of it as one force, because it's, as I said, it's a combination of all the other forces. So direction of acceleration, obviously, is the way it's going. Okay? So using Newton's second law, we have F equals ma, so 75 root 2 equals mass of the object, which is 5 kilograms, times a. Okay? And to get a, you just take the 5 over and divide. So that implies then a is 15 root 2 meters per second squared. And we're done. The question is answered.